So let's see something called the potential energy. What is the potential energy? A potential energy, it is the form of energy, and that is more associated with the position or the location of the object. And we have two types of the potential energy. We have what you call gravitation potential energy, and you also have what you call elastic potential energy. What is the gravitation potential energy? This is the energy, actually, this is the energy in which the object possesses due to its vertical height. That is the actually gravitation potential energy. Whenever the object is changing the height, there is always a work done against the gravitation force. That is a gravitation potential energy. And what is the elastic energy? This is the energy possessed by compressing or stretching of the spring. So let's start with the gravitation potential energy. Gravitation potential energy. Let's say we have let's say this is the cloud, and we have an object, let's say, on the cloud. Let's say the object, it is of mass m, and assuming that the object has been lifted up, and let's say up to this point, and through the vertical height given as h. Now, what is the work done against the gravitation force as the object is attaining this, as the object has attained that height? So the work done against the gravitation force is given as mgh. And on the same case, this particular work done against the gravitation force is what you call gravitation potential energy. So that's how the gravitation potential energy can be calculated. It is given as the gravitation potential energy is equal to mgh. It is the same as the gravitation, actually it is the same as the work done against the gravitation force. So it is given in joules as well. So this is the mass of the object. This is the acceleration due to the gravity, which is always 10 meters per second square. And this is the height that is given in meters. That's what we call the gravitation potential energy. Energy associated with the height, the vertical height of the object. In other words, it is the work done against the gravitation force. So keep that in mind. And how about the elastic potential energy? How can you be able to have the elastic potential energy? Now let's say we have a spring. Let's say this is a string. Rather should be a spring, not a string. And let's say it is at its resting position. Now, assuming that the force has been applied on the spring, and so that the spring is set to stretch, let's say up to this point. And let's say the resting position, it is given as, let's say, 0. That is the resting position. It is the 0 point. And now, upon the force being applied, let me have it this way. Now, upon the force being applied, the spring has stretched. The spring has stretched up to this point. From the resting position, the spring has been stretched up to this point. And let's consider the actual stretching of the spring given as A. That is the stretching or we call it as an extension. That is the magnitude of the extension, or the magnitude in which the spring has been extended. And let's say this is the force that has been applied. And now, since the force has been applied from a zero, actually from a 0 point, because you have to understand that at first there was a zero force that was being applied on the spring, a zero force that was being applied on the screen, and that by the passing of the time the force has been increased up to this point. Now, since the string is said to be stretched up to this point, then there is elastic potential energy due to the stretching of the spring. And what is that energy? Elastic potential energy, it is given as the average force and the times the extension of the spring. And what is the average force? Since the force has been increased from 0 up to some actually point F, then the average of the force will be given as 0 plus F that divided by 2, because we are looking for the average of the two forces from the point in which the object, from the point in which the spring was at least where the force was 0, and from the point where the force has been increased up to this point, and making the spring to stretch. So the average force is given as 0 plus F, and it times the extension. Mind you, extension is given in meters. Now in this case, this is the same as having it as the elastic potential energy being given as F over 2, and it times the extension. So that's how the elastic potential energy can be calculated. Even if the spring is to be compressed, more, there will be elastic potential energy due to the spring, due to the compression of the spring. So keep that in mind. So let's say this is the question. A crane is used to lift a body of mass. Now we have the mass, that is 50 kilograms, that is the kg. Mind you, the mass has to be always in kgs. Now through the vertical height, that is the height, that is 10 meters. Now calculate the gravitation potential energy stored in the body. So we are looking for the gravitation potential energy. And what is the formula for the gravitation potential energy? Now the formula for the gravitation potential energy, it is given as the mgh. So that's how the gravitation potential energy is calculated. And you should have to understand that the gravitation potential energy varies with the height, because the mass of the object remains the same, and also the value of the gravitation the value of the acceleration due to the gravity is a constant. So which means as the height is being increased, it means the object possesses or stores the more actually gravitation potential energy. You know, the higher the object actually goes, the more actually gravitation potential energies the object possesses. And as the object is reducing, or as the object is lowering the height, it means the gravitation potential energy is said to be actually decreasing on the same note. So as the gravitation potential energy decreases, it means there is an increase in the kinetic energy, as we are going to look up to that in the upcoming next videos. But now that's how you have to understand about how we can be able to tackle up this problem in this case. So try to have that at your own space. And also let's consider this question. A stone of mass, that is the mass, we have it as 100 grams. And mind you, this mass has to be in kgs. Is projected vertically upwards, so which means the stone has been actually thrown vertically upwards, that is from the ground, with an initial velocity that is 10 meters per second. Now calculate the gravitation potential energy. Now we are looking for the gravitation, that is gravitation we are looking for the gravitation potential energy, and at the maximum height. Let's say this is the maximum, should be at the maximum height reached by the stone. So which means as the stone has been thrown straight upwards, it reaches a point where the stone will no longer go up, will no longer further go up. That point is said to be the maximum point. That is the maximum point, and the velocity there, it is given as L, and we go it as a Vmax. That is the velocity at the maximum point. That is given as L. So with initial velocity and the final velocity, and also in the same case, there is acceleration due to the gravity, which is a negative 10 meters per second square, since the object is actually going upwards. So that is negative 10 meters per second square. That is the acceleration due to the gravity. Now we can be able to have the height of the object from the ground level up to this point. That will be used to have the gravitation potential energy. So try to have that. So how can you be able to have the height if this is the case? Now we use the concept of the free fall motion, and this is a one-way upwards motion. If you can recall on the concept we discussed about the free fall motion, we talked about the several cases of the free fall motion. We talked about one way down, one way up, and also ground back to ground case, where the object has been released from the ground level and back to the same ground level. And I also talked about that of a top up ground case, where the object has been released from the top, and after some time the object has landed on the ground level. So we talked about all this. So for this case, it is a case of, should be a one-way up motion. So how should you be able to have the height in that case? Now the height will be obtained upon using the formula which is given as v square is equal to u square. Now we use the negative 2gh since the object is going upwards. So this is the velocity at the maximum point, which is Vmax, and we have the initial velocity to be able to have the height in that case. So that's how you should have to understand that in that way. So most of the problems in physics are more related with one another, so you can be able to have something from another concept, so you don't need to forget things. Once you have been taught, learn to practice a lot, and for you to be well conversant with the concept. Now calculate the elastic potential energy. That is elastic potential energy, that's what we're looking for, and are stored in a spring when stretched through, that is extension, 6 centimeters. Of course has to be in meters, you should have to convert that. And by the force, what is the force? That is given as the 4 newtons. So how should you have the elastic potential energy? The formula says the average force and the times the extension. So this is the formula you should have to use in that case. So try to see how you can be able to work it out. And also let's consider this question. A force of 9 newtons, and we have the force, that is the 9 newtons, that stretches a certain spring by extension, that is 10 centimeters. Of course has to be in meters, you should know that. Now how much work is actually done in stretching the spring by 15 centimeters? So we should calculate the elastic. Mind you, a work done is the same as, you should know that elastic potential energy, with potential energy, it is the same as the work done, only that elastic potential energy, or just say potential energy, it is another form of a work done, so it is the same as the work done. So elastic potential energy, we should calculate the elastic potential energy when the extension is about 15 centimeter. So how should we have the elastic potential energy when the extension is 15 centimeter? So the formula for the elastic potential energy, it is given as the force divided by 2 times the extension. Now what is it that it is lacking now? What we do not have is the force. So what is lacking? That should be, by the way, should have 2 here. We have the extension, but what is lacking now, it is the value of the force. So in this case, the force that we're looking for, it is this actually a given force. Then we'll be able to have the elastic potential energy using this formula. So which means this actually a 10 centimeter will not be used. But we can also be able to have the actual elastic potential energy with this 10 centimeter as well. So keep that in mind. And let's appreciate this question. An object of mass 4 kg, that is the mass, we have it as a 4 kg, and is released from the height of, you should know that this is this case, released from the height of, which means the initial velocity is 0, and this is the height, which is given as 8 meters, and above the ground. Now calculate the gravitation potential energy of the object release. So we're looking for the gravitation potential energy, which is mgh. So we can be able to have that. And the question B says that find the velocity of the object just before it strikes the ground. So we'd like to have the final velocity at this point. And which formula should we use? That is v square is equal to u square and plus 2gh. So it is a case of the free fall motion. It is a case of a free fall motion where acceleration due to the gravity will be positive. So that's how this question can also be actually tackled up. So try to come across more questions that you should be able to practice from different books, and to familiarize yourselves with the concept. Thank you.